Hello friends, welcome back to my channel TechnoRays. Before going into the next concepts of natural language processing, please like and subscribe to my channel and click the bell icon to get new video updates. So the strategy used in deep parsing is it will consider or it will give complete syntactic structure of a sentence. So some cases we need to go for semantic parsing in order to understand the complete meaning of a sentence. So mainly this deep parsing is required if the application is quite complex. So we can't go with shallow parsing in that case because there we need to understand meaning of a sentence. So in deep or full parsing, so grammar concepts like context-free grammar or probabilistic context-free grammar and search strategy, they are used to give complete syntactic structure to a sentence. And this deep parsing, it produces full parse trees where the syntactic function, like it can be part of speech tagging for each word or phrase. So syntactic function of each word or phrase is tagged with short label. So we'll be assigning labels to words or phrases in the sentence. So how the labels are assigned. So if it is noun phrase, we can assign NP. If it is verb phrase, VP. So like that, short label will be assigned to words or phrases. And this is the example or difference between example which shows difference between shallow parsing and deep parsing. So in shallow parsing, you can see this. So right side of this picture gives you shallow parsing, where if, for example, the sentences the team played, in that case, we'll just identify, first we'll identify or we'll divide the sentence into multiple tokens. And in step 2, we'll assign POS tags to every word in the sentence. And after that, we'll generate or we'll create or we'll extract phrases from the sentence. So here you can see the words are divided into 3 parts, like the team. So the team played, full stop. So after that, tags are assigned. The is determiner, team is noun, played is verb, and this dot is punctuation. In third step, we need to find out phrases from the sentence. So you can identify this as noun phrase, determiner followed by noun. So the team is considered as a noun phrase and played is taken as verb phrase. So this is shallow parsing. Whereas deep parsing, it gives you complete syntactic structure of a sentence, or it will create full parse tree. So here you can see the parse tree where short labels are assigned to phrases, or here you can see short label is assigned to this word, right? So the team played, it is represented in the form of a parse tree. So as the team is nothing but it's a noun phrase. So first we are taking this. So the is taken as determiner and team is taken as noun. So this combination gives you noun phrase. And played is a verb. So verb alone is nothing but verb phrase. And at the end we have punctuation. So S indicates it's a root or it is a sentence. So here played. So the team, they are represented as subject. As the term played is, it comes under past tense. Tense which is used is past. So in this way, it will provide complete structure of a sentence. So that is the main difference between shallow parsing and deep parsing. So this is some description regarding the previous picture. And the next concept is parse tree and syntactic ambiguity. So when can we say that the given grammar is ambiguous? So if we are able to generate more than one parse tree from that grammar or from the given productions, then we can say that the sentence is structurally ambiguous, right? So here we are taking sentence. So the ambiguity in the question, that we call it as prepositional phrase attachment ambiguity. So which is nothing but ambiguity about attachment. Since here, if you take this example, let us take example as sentence as the dog saw a man in the park. So here we can find ambiguity about attachment since the PP in the park. So this is PP, which connects three words in the park, or which is attached to three words in the park. So that needs to be attached to one of the two places in the tree. So in the first case, you can see this PP, it is considered as a child of VP. So in our first tree, this PP is taken as child of VP. Or what can be the second scenario? It can even be taken in your second parse tree. You can see this same PP. It is taken as, or it appeared as child of NP. So like that, we got two parse trees for this sentence. In the first case, PP became child of this verb phrase, whereas in the second case, it became child of noun phrase. So because of this, the scenario changes or the interpretation of the sentence changes. So in the first scenario, the first parse tree, when PP is attached to this VP, the intended interpretation is that the seeing event happened in the park. So if you take this right subtree, so when this PP is attached to NP, it indicates that this seeing event. So in this part, we have saw a man in the park. That means seeing event, it happened in the park. It clearly states this scenario. Whereas if you take the second parse tree, if the PP is attached to this noun phrase, then it indicates that it was. Now we need to consider this part only. Right subtree of this VP. So what this indicates, there is no seeing event. So in this part, we just have a man in the park. So where, who is seeing? The dog is seeing. And it is not clear that whether the dog is in the park or whether it is seeing from somewhere. So here we might assume that, suppose the dog, it might be seeing a man who is walking in the park from balcony in the apartment. Even that can be one scenario, or it can be one interpretation. Like that, interpretations will change based on the tree which we generated. So in the first case, as we have this complete one in this right subtree, it indicates that this saw event, it happened in the park only. Whereas in this case, it is not like that. Man is sitting in the park or man is walking in the park, but this saw event or this dog, it saw the man from somewhere. Okay, we don't know from where this dog saw the man, but it is clear that man is in the park. So in this way, we can generate more than one interpretation. In the same way, you can take second example, time flies like an arrow. So for this also, you can generate more than one parse tree. So here we generated 4 parse trees for this example. So based on the previous knowledge or based on example 1, try to solve this example 2. So this is nothing but syntactic ambiguity. Hope the things are clear to you. Thank you.